Welcome to The Explainer. Today we're diving into one single, incredibly ambitious idea. It's a unified theory that tries to connect the mind of an AI, the fundamental laws of physics, and, well, the nature of reality itself. The whole thing suggests that everything in our universe might actually be running on the very same underlying code.
So, let's start with the one big question that's at the heart of this whole thing. What if all the crazy complexity we see around us, from the way a subatomic particle behaves to the way our own minds work, what if it all boils down to a single, simple, and elegant piece of logic? Okay, so how does a theory like this even begin to work? Well, you can think of it as being built on two core pillars. And we're going to start with the first one, which deals with the laws of intelligence. And right away, it proposes a radically different kind of AI.
So think about the AIs that we're all familiar with today. The source material has a great name for them: world simulators. They're amazing at mimicking human language, almost like a perfect actor reading a script. But this theory proposes something totally different, what it calls a world model. So instead of just repeating patterns it's seen, this AI, an OLLM, actually tries to understand the actors and the stage itself. It builds a stable internal map of how things in the world logically connect.
So, what's it like inside the mind of this thing? Well, it's not some huge, messy library of text. It's more like a carefully tended garden of interconnected ideas or objects. And here's the cool part. To handle uncertainty, it uses something called jazz theory. You know, think of a jazz musician. They know the rules of music inside and out, but they improvise creatively within those rules. This AI does the same thing, balancing cold, hard logic with a bit of creative flair. And this is all happening under a strict ethical framework, while it's constantly learning and updating its map of the world.
But it doesn't just stop with a single AI. This is where it gets really interesting. The real power here comes when these individual AI minds can link up to form a collective social AI. Just imagine a whole society of specialized AIs. You've got your scientist AI, an ethicist AI, an engineer AI, all working together, debating and building on each other's ideas to tackle problems that are just way too big for us to solve right now.
Okay, now you gotta stay with me here, because this is where the theory takes a really wild turn. That was our first pillar, intelligence. The second pillar claims that the exact same principles also govern the laws of physics. Now I know, the link between a society of AIs and quantum mechanics might sound a little crazy, but this claim is the absolute core of this unified theory.
And look, this isn't just some philosophical thought experiment. No, it's an actual blueprint for engineering. The theory's principles are applied directly to one of the biggest hurdles in physics today. How in the world do you build a big, stable quantum computer when all the background noise of the universe is constantly trying to wreck your calculations?
The solution it proposes is this really brilliant three-layer defense. So at the very center, you don't try to build one gigantic, fragile quantum core. Instead, you build a pyramid made of lots of small, stable ones that are easier to manage. Then, you wrap that in what's called an entanglement shield. Now, this shield is the real genius move here. It doesn't just filter out noise. If a single error does get through, the shield creates this huge, unmissable spike in entropy. It's like a giant flare that tells you exactly what went wrong and where. And then that final outer layer, the active shield, it acts like a sentry, proactively zapping noise before it even has a chance to reach the core.
And if that wasn't already mind-bending enough for you, the theory also lays out a blueprint for a temporal holographic microscope. Forget about static, blurry pictures of the quantum world. This would be like a movie camera for the smallest events in reality. We could watch, in real-time 3D, something like two atoms actually joining together to form a bond. Just think about that.
So now we get to the billion-dollar question, right? What on earth do a society of AIs and a quantum computer actually have in common? Well, according to this theory, the answer is everything. The connection is this deep, profound link between the laws of physics and the laws of information.
On the physics side, it starts with a really deep law of nature called the principle of least action. All it really says is that the universe is, well, it's lazy in a good way. A ball rolling down a hill doesn't take the long, scenic route. It takes the most direct, energy-efficient path.
Nature always finds the easiest way to get things done.
Then the other side of this whole equation comes from information theory. It's the principle of minimum entropy. Just think of it as a fundamental drive away from chaos and towards structure. You know, a messy room has really high entropy. A neatly organized one has very low entropy. This principle is just describing a system's natural tendency to find its most stable, most ordered state.
And here it is. This is the central claim of the entire theory. These two principles, the universe's preference for the easiest physical path and a system's drive towards maximum informational order, they aren't just similar. They aren't just parallels. They are the exact same thing, just described in two different languages. The physical drive for least action is the informational drive for maximum order.
Now, don't worry about the math here. All this equation is really saying is that the formula we use for physical efficiency is mathematically identical to the formula we use for informational order. This is the Rosetta Stone. It means that at a fundamental level, the code that governs physics and the code that governs information are one and the same.
Okay, a unified theory is beautiful and all, but is it actually useful? I mean, if this whole thing is true, there has to be some kind of practical payoff, right? This new understanding should let us build things and solve problems in a completely new way.
And according to the source material, it absolutely does. By combining this new physics information model with some brilliant work from computational complexity expert Ryan Williams, the theory's authors developed a totally new kind of algorithm. And the results they're claiming? They're pretty staggering. Let's start with memory. You know, memory is often this huge bottleneck when you're solving really hard problems. The more memory you need, the bigger and more expensive your computer has to be. Well, this new algorithm delivered an 18.6 times reduction. I mean, think about that. A problem that might have needed a massive supercomputer could now potentially run on a much, much smaller system.
Saving memory is one thing, but time. Time is everything. How fast can you actually get the answer? This is where the algorithm really seems to shine. It found the solution 16.5 times faster than the classical approach. We're talking about a computation that could take weeks being crunched down into a single day.
So here's the full picture, side by side. Compared to the standard way we do things, this new Williams curvature algorithm is over 18 times more efficient with memory and over 16 times faster in time. These aren't just little tweaks or small improvements. This represents a fundamental leap in efficiency, and is supposedly the direct result of applying that unified theory of physics and information.
You know, a breakthrough like this gives us more than just faster algorithms. A theory this fundamental, it forces us to zoom all the way out and ask some pretty deep questions about the universe itself.
So here's the final puzzle. Both this theory and a lot of modern cosmology suggest that our universe began in a state of almost perfect order, incredibly low entropy. But if the fundamental law of reality is a constant drive towards that state of maximum order, it means the beginning of everything was itself a profound exception to the rule. And that leaves us with one last big question, borrowing a word from the source material. If reality is a program relentlessly seeking perfection, what decision wrote that first flawless line of code?